Hello students, and welcome back to another episode with me, the Pillow Professor. I'm so glad you've joined me for tonight's journey because we're diving deep into one of Earth's most powerful, mysterious, and awe-inspiring wonders, volcanoes. Tonight, we're going to explore how volcanoes are born deep within our planet, the different types and personalities they can have, and the science behind their fiery eruptions. We'll wander through stories of legendary eruptions that changed history, learn how volcanoes can shape our climate, and discover the hidden volcanoes lurking beneath the ocean's surface. But that's not all. We'll also look far beyond Earth to volcanoes on other planets, marvel at volcanic lightning, and even hear the mighty voices of volcanoes rumbling through the ground. We'll dive into obsidian's shimmering beauty, the secrets of lava lakes, and the gift volcanoes bring to human life, from fertile soils to geothermal power. And we'll talk about how scientists keep watch over these sleeping giants. So fluff up your pillow, settle in, and get ready to drift through rivers of molten rock, thunderous explosions, and landscapes shaped by both fire and time. And before we begin, don't forget to hit that like button, subscribe to the Pillow Professor, turn on those notifications so you never miss a cozy lesson, and drop me a comment telling me if you learned something new by the end of tonight's video. Volcanoes are Earth's way of letting off a bit of steam, but how exactly do these mighty mountains come into existence? It all starts deep beneath our feet, in a region known as the mantle. Down there, immense heat and pressure melt rock into a thick, flowing substance called magma. This magma is lighter than the solid rock above it, so it pushes upward, searching for any cracks or weaknesses in Earth's crust. Over time, these rising plumes of magma can force their way to the surface, bursting through to form a volcano. Sometimes magma finds a quick escape through thin oceanic crust, creating volcanic islands like Hawaii. Other times, it pushes through thicker continental crust, building massive peaks such as Mount St. Helens. It's a bit like soda bubbling up through a straw. Pressure builds, and sooner or later it's going to explode out. It's astonishing to realize that beneath us, Earth is constantly churning, brewing up these fiery spectacles. And though we walk around on what seems like solid ground, there's an entire world of molten rock in motion beneath our feet. Now that we know how volcanoes are born, let's explore the different personalities they can have. Volcanoes aren't all the same. They come in various shapes and sizes, each with its own temper. First, there are shield volcanoes, like those in Hawaii, which look like enormous warriors' shields lying on the ground. These volcanoes have gentle, sloping sides because their lava is very fluid. It can travel long distances, forming broad, wide mountains instead of tall, pointy peaks. Mauna Loa, for instance, rises more than 30,000 feet from its base on the ocean floor to its summit above sea level, making it the largest volcano on Earth. Then we have stratovolcanoes, also called composite volcanoes. These are the classic cone-shaped giants like Mount Fuji in Japan or Mount Rainier in Washington. Their eruptions can be much more explosive because their lava is thicker, trapping gases until pressure builds enough to blow the mountain apart. These volcanoes can rise over 10,000 feet, towering over landscapes and sometimes entire cities. Cinder cone volcanoes are smaller, yet no less fascinating. They erupt blobs of lava into the air, which cool quickly and fall around the vent, piling up into steep cones that may only stand a few hundred feet tall, like 300 feet. Despite their size, these eruptions can be quite spectacular, lighting up the sky like a dazzling fireworks display. And then there are caldera volcanoes. When an eruption empties a volcano's magma chamber so dramatically that the mountain can no longer support itself, it collapses inward, creating a vast depression called a caldera. Crater Lake in Oregon is one such caldera, its serene blue waters hiding the violent story of Mount Mazama, which erupted around 7,700 years ago. Each of these volcano types has its own signature style, from slow, graceful flows to explosive, sky-darkening blasts, showing that volcanoes are as diverse as they are powerful. Let's talk about the real star of the show, the eruption itself. What makes a volcano blow its top? It's all about pressure and gases trapped in the magma. Magma contains dissolved gases like water vapor, carbon dioxide, and sulfur dioxide. As magma rises toward the surface, the pressure decreases, and these gases start to expand, forming bubbles. If the magma is thick and sticky, the bubbles can't escape easily. Pressure builds and builds until the magma bursts through the surface in a violent eruption, sending ash, rock, and molten lava hurtling into the sky. Think of it like shaking a bottle of soda and popping the cap. If the liquid is thick, like syrup, it explodes out with tremendous force once released. The speed and violence of an eruption also depend on how much silica is in the magma. Magma high in silica tends to be thicker and more explosive. Magma with less silica, like that in shield volcanoes, flows more easily, creating gentle lava streams rather than earth-shaking explosions. During eruptions, temperatures of lava can reach up to 220 degrees Fahrenheit. The molten rock glows brilliant orange or red as it flows across the landscape, sometimes moving slowly at just a few feet per minute, or in rare cases, racing downhill at up to 30 miles per hour. Volcanoes also release volcanic ash, which might sound soft and fluffy, but is actually made of pulverized rock and glass shards. These tiny particles can travel thousands of miles on the wind, disrupting air travel and even lowering global temperatures if the eruption is large enough. So the next time you see footage of an eruption, remember, there's an entire orchestra of gases, pressure, heat, and chemistry at work behind that fiery display. Volcanoes don't just change landscapes, they can change the course of human history. Let's drift back in time to some of the most significant volcanic events ever recorded. One of the most famous is the eruption of Mount Vesuvius in 79 AD. The people of Pompeii and Herculaneum were going about their lives when Vesuvius exploded, spewing a cloud of ash and gases over 20 miles high into the sky. Within hours, the cities were buried under ash and pumice, preserving homes, artwork, and even food in astonishing detail. It's thanks to this tragic event that we have such an intimate glimpse into life in ancient Rome. Another legendary eruption was Krakatoa in 1883, located in Indonesia. When it erupted, the explosion was heard over 3,000 miles away. That's roughly the distance from San Francisco to New York. The blast sent shockwaves around the globe multiple times and generated tsunamis over 100 feet high, or about 30 meters, devastating coastlines and killing tens of thousands of people. The eruption spewed so much ash into the atmosphere that global temperatures dropped by more than 2 degrees Fahrenheit for several years afterward. Then there's Tambora, also in Indonesia, which erupted in 1815. This eruption was so massive that it led to what's called the Year Without a Summer in 1816. Crops failed across Europe and North America, leading to food shortages, famines, and some of the coldest summer weather on record. The eruption ejected an estimated 36 cubic miles of material and caused the deaths of tens of thousands, both directly and through subsequent famine. Volcanoes have shaped not just landscapes, but economies, cultures, and even climate. Their power reaches far beyond their fiery slopes, leaving marks on history that echo for centuries. Despite their destructive reputation, volcanoes also bring incredible gifts to our world. The same forces that create eruptions also create fertile soils, breathtaking landscapes, and even precious resources. Volcanic soil is incredibly rich in minerals, making it perfect for agriculture. Regions like the slopes of Mount Etna in Italy or the fields around Mount Fuji produce abundant crops thanks to these nutrient-rich soils. Grapes for some of the world's finest wines grow in volcanic regions, benefiting from the minerals left behind by ancient eruptions. Volcanoes also create stunning natural features, from rugged mountain peaks to shimmering lakes hidden in calderas. Tourists flock to places like Iceland or Yellowstone National Park to witness geysers, hot springs, and other volcanic wonders, all fueled by underground heat. Speaking of heat, volcanoes provide geothermal energy. Countries such as Iceland harness this power to heat homes, generate electricity, and even keep sidewalks ice-free during the winter. It's a clean, sustainable energy source that taps into the same heat that fuels eruptions. Volcanoes also give us valuable minerals and metals. Elements like sulfur, pumice, obsidian, and even precious metals such as gold and silver can be found in volcanic regions. Obsidian, with its glossy, black appearance, was used for tools and weapons in ancient times and is still used today in fine surgical instruments. So, while volcanoes might seem like fiery destroyers, they're also creators, builders and providers, shaping Earth's landscapes and giving us gifts that enrich our lives in countless ways. Students, did you know that most of Earth's volcanic activity happens out of sight, deep beneath the ocean's surface? Underwater volcanoes, called submarine volcanoes, are scattered along ocean ridges and seafloor cracks where tectonic plates pull apart. When these volcanoes erupt, molten rock spills out into icy seawater, cooling instantly and forming new ocean crust. Over millions of years, these eruptions build vast underwater mountain chains like the Mid-Atlantic Ridge, which stretches more than 10,000 miles. Sometimes submarine volcanoes grow tall enough to break the ocean surface, creating islands like Iceland or the Hawaiian Islands. Others remain hidden, shaping ecosystems that thrive around hydrothermal vents where superheated, mineral-rich water gushes out, supporting strange creatures like giant tube worms and blind crabs that would look more at home in a sci-fi movie. So next time you look at a map of Earth, remember that beneath those blue ocean depths, volcanoes are busy building mountains and hosting alien-like life forms far from human eyes. Now, let's talk about some of Earth's sleeping giants, the supervolcanoes. These colossal volcanoes are so massive that a single eruption could have global consequences. One of the most famous is the Yellowstone supervolcano in the United States. The Yellowstone caldera measures about 30 miles long and 45 miles wide. The last major eruption, around 640,000 years ago, ejected over 240 cubic miles of material and left behind the massive caldera that visitors see today. If Yellowstone erupted on the same scale again, it could cover vast areas of North America with ash several feet thick, disrupt global weather patterns, and trigger a volcanic winter lasting years. Fortunately, scientists closely monitor Yellowstone for signs of unrest, and there's no indication it's about to erupt anytime soon. Other supervolcanoes exist around the world, like Lake Toba in Indonesia, which erupted 74,000 years ago, or Taupo in New Zealand. These giants remind us that Earth's power can sometimes slumber for millennia, only to awaken in events that reshape our entire world. As if volcanoes weren't dramatic enough, some eruptions put on a spectacular electric display known as volcanic lightning. When a volcano erupts explosively, it blasts ash, rocks, and gases high into the atmosphere. As all these particles collide, they generate static electricity, creating bolts of lightning that flash inside the ash cloud. One of the most striking examples was the 2010 eruption of Eyjafjallajökull in Iceland, where lightning danced through towering ash plumes, creating scenes so surreal they looked like paintings come to life. Volcanic lightning can be dazzling, but also dangerous, as the electrical discharges can ignite fires or damage sensitive equipment. Scientists are still studying exactly how these incredible electrical storms form, but one thing is certain: they add yet another layer of drama to an already powerful natural phenomenon. Volcanoes aren't exclusive to Earth, students. Our entire solar system is sprinkled with volcanic landscapes, some far more extreme than anything found here at home. Take Mars, for instance. It's home to Olympus Mons, the largest volcano in the solar system, towering about 72,000 feet tall and stretching nearly 370 miles across. That's so large it would cover the entire state of Arizona. On Jupiter's moon Io, volcanic activity is so intense that molten lava fountains erupt into space, creating plumes over 200 miles high. The entire surface of Io is constantly being reshaped by eruptions, making it the most volcanically active body in the solar system. Even Venus has vast volcanic plains and enormous volcanoes, though they remain hidden under thick clouds of toxic gases. Exploring volcanoes beyond Earth helps scientists understand planetary geology and how worlds evolve over time. Volcanoes have long held a special place in human culture, inspiring myths, legends, and even religions. Many ancient peoples believed that volcanoes were the homes of gods or spirits. The ancient Romans thought that Vulcan, the god of fire and metalworking, lived beneath Mount Etna in Sicily, forging weapons for the gods. In Hawaii, Pele, the goddess of volcanoes and fire, is said to dwell within Kilauea, shaping the land with her fiery temper. Volcanoes have also inspired countless works of art, literature, and film, symbolizing everything from destruction to rebirth. Whether they're depicted as symbols of divine wrath or the creative forces of nature, volcanoes continue to capture our imaginations. When volcanoes erupt, they release not only lava and ash, but also gases that can profoundly affect the environment and even the climate. These gases include water vapor, carbon dioxide, sulfur dioxide, hydrogen sulfide, and other compounds. Sulfur dioxide can combine with water in the atmosphere to form tiny droplets called aerosols. These aerosols reflect sunlight back into space, sometimes cooling global temperatures for months or even years. The eruption of Mount Pinatubo in 1991, for example, lowered average global temperatures by about 1 degree Fahrenheit for nearly 2 years. Closer to the ground, volcanic gases can be dangerous to breathe, causing health problems for people living near active volcanoes. But on a planetary scale, volcanic gases are a crucial part of Earth's carbon cycle and have shaped the atmosphere over geological time. Because volcanoes can erupt with little warning, scientists have developed alert systems to help keep people safe. These systems use a combination of seismographs to detect earthquakes, GPS to measure ground deformation, and gas sensors to sniff out changes in volcanic emissions. Alerts range from normal conditions to higher levels, indicating increasing unrest or an imminent eruption. Governments and local authorities use these warnings to evacuate people, close airports, and prepare emergency responses. Thanks to advances in technology, scientists today can often predict eruptions with greater accuracy than ever before. Although not perfect, these systems save lives and help reduce the risks posed by Earth's fiery mountains. Imagine standing at the edge of a pit glowing red with molten rock, swirling and bubbling like a pot of soup. That's a lava lake, a rare phenomenon where molten lava pools in a crater, sometimes for years at a time. One of the most famous examples is the lava lake at Mount Nyiragongo in the Democratic Republic of the Congo. Its lava lake has measured over 600 feet deep at times, with temperatures above 2,200 degrees Fahrenheit. When cracks in the volcano's flanks open, this molten lake can drain catastrophically, sending lava rivers racing through nearby cities. Lava lakes are mesmerizing yet dangerous, offering scientists a unique window into volcanic behavior and magma chemistry. Volcanoes draw millions of tourists every year, eager to witness nature's power up close. From hiking across cooled lava fields in Hawaii to soaking in geothermal hot springs in Iceland, volcanic landscapes offer experiences found nowhere else. However, volcano tourism comes with risks. Sudden eruptions, toxic gases, and unstable terrain can turn an adventure into a life-threatening situation. In 2019, the eruption on White Island, New Zealand, tragically underscored the dangers when tourists were caught in an unexpected explosion. Despite these dangers, volcano tourism contributes significantly to local economies and helps people connect with Earth's dynamic forces. Visitors just need to follow safety guidelines and respect the power of the volcanoes they've come to admire. Students, did you know that many earthquakes are linked directly to volcanic activity? Before a volcano erupts, magma often forces its way through cracks and fractures in Earth's crust. This movement creates seismic waves, vibrations we feel as earthquakes. Volcanic earthquakes tend to be shallower and localized compared to tectonic quakes caused by shifting plates. Scientists pay close attention to these volcanic tremors because swarms of small quakes can signal magma rising toward the surface. For instance, in 1980, Mount St. Helens in Washington state rumbled with thousands of small quakes for weeks before its explosive eruption. These seismic signals were crucial warning signs that helped scientists predict the catastrophic blast. So next time you hear about earthquakes near a volcano, remember, it's often the Earth's way of sending a message that pressure is building and something fiery may be on the way. Volcanoes aren't just spectacular to watch, they're also incredible to hear. Many produce deep, thunderous sounds long before they erupt. These booming noises, called volcanic tremors, happen when magma pulses through narrow channels underground, vibrating rock like the walls of a musical instrument. Some volcanic eruptions produce shock waves that travel great distances. When Krakatoa erupted in 1883, its blast was so loud that people heard it more than 3,000 miles away from the island itself, all the way to Australia, and even the island of Rodrigues near Africa. It remains the loudest sound ever recorded in human history. Modern technology uses special microphones called infrasound detectors to pick up low-frequency sounds from volcanoes. These sounds help scientists track eruptions even when clouds, darkness, or ash make it impossible to see what's happening. So, while volcanoes are silent most of the time, when they decide to speak, they often roar with a voice that can echo across continents. Students, let's explore one of the most beautiful and mysterious gifts of volcanoes, obsidian. Obsidian is a natural volcanic glass formed when lava rich in silica cools so quickly that crystals don't have time to form. The result is a smooth, shiny rock with a glassy surface that can be as black as midnight, deep mahogany, or even shimmering rainbow colors depending on trace minerals trapped inside. In ancient times, obsidian was prized for its sharpness. Early humans crafted razor-like blades, arrowheads, and tools that were sharper than steel. Even today, some surgeons use obsidian scalpels because their edges can be just a few nanometers thick, making them far sharper and smoother than traditional steel blades. Beyond its practical uses, obsidian has held spiritual and cultural significance in many civilizations. The ancient Aztecs and Mayans believed obsidian had protective powers and used it for ceremonial mirrors to see visions or communicate with spirits. Volcanic glass, like obsidian, reminds us that even in the aftermath of fiery eruptions, Earth creates objects of incredible beauty and utility. It's a perfect symbol of how destruction and creation often go hand in hand in the natural world. Looking ahead, Volcanoes will continue shaping our world in ways both dramatic and subtle. Scientists are developing new tools like drones and satellite imaging to monitor volcanoes more safely and effectively. There's also interest in how volcanic processes could be harnessed to mitigate climate change, like using basalt rock to capture and lock away atmospheric carbon dioxide. Even in space exploration, our understanding of volcanoes might help us find life on other worlds. The heat and chemicals from volcanic activity could create habitable environments beneath the icy crusts of moons like Europa or Enceladus. So, while volcanoes may seem like ancient relics of Earth's past, they remain as relevant as ever to our future, continuing to shape the planet, and perhaps even offering keys to exploring the stars. And there you have it, students. A journey into the heart of Earth's fiery wonders. Tonight, we've explored how volcanoes are born in the depths of our planet, the many forms they take, and the incredible forces that drive their eruptions. We've wandered through ancient cities frozen in time by ash, witnessed lightning crackling through volcanic plumes, and travelled all the way to distant planets where volcanoes rise taller than any mountain on Earth. We've discovered how volcanoes can cool our climate, shape entire landscapes, and even produce dazzling treasures like obsidian. We've heard the deep rumblings that warn of eruptions and learned how modern science keeps watch over these powerful giants to protect the people living in their shadows. Volcanoes are true reminders of Earth's dual nature, destructive yet creative, dangerous yet profoundly beautiful. They teach us that even in moments of chaos, there's the potential for new beginnings, fertile lands, and breathtaking natural wonders. Thank you for joining me tonight, students, on this volcanic adventure. I hope you're feeling inspired, a little wiser, and maybe even dreaming of glowing lava lakes and distant Martian peaks. Remember, if you enjoyed our lesson, give this video a like, subscribe to The Pillow Professor, and turn on your notifications so you never miss a cozy night of learning. And tell me in the comments, what did you learn tonight that surprised you the most? Until next time, sleep well, stay curious, and keep dreaming of the wonders hidden within our amazing planet. Good night, students.